All right, hello and welcome. Today, we are going on a journey. We're going to take a design pattern that a lot of us know, the factory, and we're going to evolve it step by step from a pretty good idea into something that is truly brilliant, flexible, and super resilient.
But first, let's start with a feeling I'm pretty sure we've all had. You build something, it works perfectly, right? But then, the moment you need to add a new option, a new type of feature, you have to go back and crack open code that was already working. It feels fragile, it's risky, and honestly, it's just a pain.
So, here's our game plan. First, we'll talk about why we even need factories to begin with. Then, we're going to find a pretty common flaw in the simple versions and, of course, fix it. And finally, we'll level up to build what I'm calling the ultimate flexible factory. It might just change how you think about creating objects. Okay, let's start at square one. What problem is a factory even trying to solve? Well, it all boils down to how we make things, how we create objects in our code. You see, when your main code is full of lines like new linear iterator here and new random iterator there, it gets really tightly coupled to those specific classes. Your application code knows exactly how to construct these things, and that knowledge makes it super rigid. If you need to change how one is made, you've got to hunt down every single place you used it. Let me give you an analogy. Imagine you need a pen. You don't build a pen-making machine in your living room, right? No, you go to a supermarket. The supermarket is your factory. It's got all the different kinds of pens, and you just go and ask for the one you want. The supermarket deals with how it got there, you just pick the one you need. That's the whole idea. And that leads us to our first real improvement. So before, we see we're creating the iterator directly. But after, we ask this thing called an iterator factory to do it for us. We just say, hey, can I get a linear one? And the factory handles all the messy details. It's way cleaner, and all that creation logic is now in one single place. But, and this is a big but, this simple approach, which is usually built with a bunch of if-else statements, has a major architectural problem hiding just under the surface. Let's see what happens when we try to add something new. So, yeah, the boss comes in and says, we need a new feature. Let's play songs in reverse. Cool. We create our new reverse iterator class. But now what? How do we tell our factory about this new kind of iterator? Well, with this simple approach, we have to go back into the iterator factory file and physically add another else if block. And this is a huge red flag. We are modifying existing, tested, working code just to add a new feature. It seems small, but this is how codebases become fragile over time. What we're doing here violates the O in the solid principles, the open-closed principle. It's a fancy way of saying our code should be open for extension, we should be able to add new stuff, but closed for modification. We want to add that new reverse iterator without ever touching the original factory's code. Okay, so how do we fix this? Well, the first big leap forward is to just get rid of that brittle if-else chain and replace it with a map. Then we can create a register method that lets outside code add new iterator types to our map whenever they want. Now our get method becomes super simple. It just looks up the type in the map and returns it. And just like that, it works. We can add a reverse iterator or a shuffle iterator or whatever we want just by calling register. Our factory is now open for extension, but closed for modification. The open/close principle is happy. We did it. Mission accomplished, right? Well, not quite. See, there's a much deeper, more subtle problem with this map-based approach. And solving that problem is what leads us to the final and most powerful solution. The question we really need to be asking ourselves is not how we store these iterators, but when are they actually being created? With our current map solution, the object gets created the second we call register. And believe it or not, that is a huge problem. Just look at this. When we register, we have to pass in a new linear iterator, and we also have to give it a specific playlist right then and there. So what happens later if we want to use that same linear logic, but with a different playlist? We can't. We'd have to register a whole new one. We've accidentally tied the creation logic to the specific data it uses, and that just kills our flexibility. So this is the key insight. The whole problem is that our factory is acting like a warehouse for pre-built objects. It shouldn't be. It should be a cookbook full of recipes. Instead of storing the finished cake, we should be storing the instructions on how to bake the cake so we can make one fresh whenever we need it. And here is that aha moment, right here in the code. We change our map. Instead of storing an iterator object, we're now storing a function that knows how to take a playlist and give us back an iterator. This isn't the object itself, it's the blueprint for how to create one. So what is this weird function playlist iterator thing? Don't let the syntax scare you. It's simply our blueprint. It's a piece of logic, a recipe that basically says, hey, I know how to take a playlist that you give me, and from that, I can produce a brand new iterator. And in modern Java, we can represent this perfectly with a simple lambda expression. So let's walk through the new flow. First, we register the blueprint. We put a little lambda function in our map. And notice, no iterator object is created at all. It's just a recipe. Then, later, some other part of our code asks for an iterator, and it passes in the specific playlist it wants to use right now. It's only at that moment that the factory finds the right blueprint, applies it to the playlist, and creates the object. Fresh, on demand, just in time. And this is the magic number, 0. That is the number of iterator objects we create when we register a new type. We're not storing objects anymore, we're just storing the potential to create them. And that is incredibly efficient and powerful. The benefits of this approach are just huge. We have completely separated the definition of how to create something from the act of creating it. The creation is delayed until the last possible second, which makes our factory infinitely flexible. This is what it means to truly follow the open/closed principle. It's a beautiful thing. So when you look back, our whole journey has really just been about applying these core software design principles. We used abstraction to hide the creation logic, we finally achieved the open-closed principle, and we used this idea of delayed creation, you might have heard it called lazy initialization, to get this incredible level of decoupling. You know, in the end, the biggest change we made was a mental one. We shifted from storing the what, the finished object, to storing the how, the recipe to create it. And that simple change in perspective is what transforms a pretty good factory into one that is genuinely dynamic and rock solid. This idea, this whole concept of delaying decisions, of storing recipes instead of results, it's a powerful pattern that you can use way beyond just factories. So the question I want to leave you with is this. Where else in your own code could you apply this thinking to make it more flexible, more dynamic, and just better? Thanks so much for joining me.